Hey everyone, this is Jason Dinsmore from OrganicChemistOnCall.com. Just wanted to make a note from the video, one of the statements that I made in periodic table in the bonds. I had said that you could think about, let's say for example, I think the example I used was oxygen, where we could either have an oxygen with two single bonds separate, or we could take those bonds and squeeze them together and put them together like this, where we have a pi bond, and then what I followed up to say is having two single bonds side by side. Now I use that terminology just to give you a different way of thinking about it. In a sense, we are kind of taking two single bonds and squeezing them together. However, as many of you know, that's not accurate. It is a pi bond. So let's look at that in terms of how that comes about. So we know carbon, we'll just kind of refresh this, we know carbon has 4 electrons around it. It's neutral. And we know oxygen wants to have a total of 6. So in order to form the bonds, we know that we're just going to bring two single electrons together, because that essentially forms a bond, so we can bring those together, and we can bring those together. And if we look at this and just rearrange this, we would have a system that looks something like that. Now it does look like those electrons are right on top of each other, as though they're kind of squeezed all within the carbon oxygen. Now we know that in chemistry that only two electrons, you can only have two electrons kind of residing in a specific space. So what that means is if we have two lines there, that's a total of 4 electrons. So the only space between the carbon and oxygen can only hold 2 electrons. So if we just redraw that, we would have our carbon, we would have our 2 electrons, and our oxygen. So that means that those other 2 electrons, we were just to put them in there, if those are in there, they have to be residing somewhere else. So where are they? All right. So let's take a look here. So if we have a carbon and we have our 2 electrons and our oxygen, this is going to be essentially in the plane. So that carbon bonded to the oxygen is going to be in the plane. Now if I just kind of draw over here an X, Y, Z axis, so we'll do X, Y, and we'll do something like this. Now what I want to point out with this X, Y, Z, it doesn't matter which one's which, but the point is that that and that are 90 degrees from each other, that and that, whoops, it's more than we needed, that and that are 90, and obviously that and that are 90 degrees. Why is that important? Well, in order to have electrons kind of reside in close proximity, they have to be what's known as orthogonal or perpendicular, where they're going to be 90 degrees from each other. So if we were to think about this, our red electrons in our CO bond, so let's just draw our, we can do our C here and our O here, those electrons are actually residing in that. So in order to get our pi bond, what we're going to have to do is put it somewhere else, either in this axis or that one. It doesn't matter, but it's going to be 90 degrees. So if we were to put our 2 electrons, we'd put them here and here, and what that actually is going to do is they're going to hover above that bond. So what we're going to actually wind up doing is, I'm going to draw this out fully, but what you wind up doing is you get kind of a blob above and below like that. So this looks obviously weirder than what we were doing before, but although we draw them representatively, where we have a carbon double bond oxygen like that, one of those bonds is between the carbon and oxygen, and the other one is up above. Another way to draw that, because sometimes this concept can be a bit confusing, so I'm going to draw this in a couple different ways. That's one way you might see it. What we could think about is single bonds. If we do this all in terms of kind of blobs, that's also a technical term. We could draw our single bond in there, and then our other electrons are going to be in p orbitals, or a pi bond, because a pi bond is p orbitals. What those are going to look like, and I think this might be a little easier to see if I kind of draw that as an axis, that obviously is going to be a 90-degree angle between that, and therefore those electrons are going to reside perpendicular in this. And then if we were just to make this to where it actually bonds, where we actually represent that, we would draw it filled in up here like that to represent our pi, and then just due to the mathematics of which we really won't get into now, that would wind up being open. But everything that I've drawn here, this one, we can get rid of that because that's the same. This one, and this one are all the same. But the point was is that I wanted to let you know that although I said they're two single bonds squished together, that's not accurate. You can think about that as you're studying, but obviously you would not want to say that on an exam or repeat that to your professor. That's just kind of a different way of looking at it, maybe to help you along the way.